Hello, hello, hello. Good morning. This is Professor Ines Gogre, Assistant Professor, Junior College of Horticulture, Nashik. The reason why I am preparing this video is due to recent outbreak of coronavirus, that is COVID-19. So, on this occasion, I will request you all to stay at home and stay safe. Before starting the lecture, that is lecture on availability, that is nutrient, plant nutrients and classification of nutrients. So, nutrient elements, and there is a criteria of essentiality by Arnon, that is a Greek scientist known as Arnon. He has put forth or laid criteria of essentiality. He told, okay, Arnon, the scientist, has put forth the criteria for essentiality of nutrients. The criteria says it is categorized into 3 points in the year 1951. The plant must be unable to grow normally or complete life cycle in the absence of particular element. The element must be unable. The element is responsible for plant to unable to grow normally. The second part is the element is a specific and cannot be replaced by another element. The element is specific, which causes deficiency. It cannot be replaced by another element. That is the second criteria. Third criteria, the element plays direct role in plant metabolism. It is directly involved in plant metabolism. These are the 3 criteria which is put forth by Arnold. It will be asked in your examination for 4 marks, and it is regularly going to be asked in your final semester examination. Okay. Then the elements which are discovered by scientists, there are uh, 17 essential plant nutrients for plants, 18 for animal, human. So elements which are present in air, soil air, that is hydrogen, carbon, hydrogen, and oxygen. The element nitrogen is discovered by Theodore de Saussure, that is named a scientist in the year 1804. Potassium, phosphorus, magnesium, and sulfur is discovered by discovered by scientists known as C. Scavenger. Then iron is discovered by scientists known as E. Grease. Manganese by G. S. M. C. Hogg. Zinc is by E. L. Sommer and C. P. Lippmann. Copper by L. Sommer and C. P. Lippmann. Molybdenum by D. L. Arnon and Stout. Then sodium is discovered by Brownell and Wood. Then cobalt is discovered by Ahmad and Evans. Then element accepted as essential for higher plants only. That is calcium, that is discovered by C. Serpengel, boron by K. Orrington, and chlorine by Brower, Johnson, and Stout, particularly. Then there are some beneficial elements that is discovered by scientists. Some first one is vanadium, discovered by unknown and vessel. Silicon by Datums by J.C. Levin. Iodine by L. Fries. Selenium by S. F. Felsen and H. M. Trill. Gallium by R. S. Steinberg. Aluminum by K. Todak. It is one of the it is asked in your image. What is plant nutrients? It is an Iron, chemical element which is responsible for normal growth and development of plant. That is known as a nutrient. Some of that is vanadium, silicon. These are known as a beneficial elements. Functional elements. Nicholas has laid down a criteria for deficiency and toxicity, deficiency and sufficiency of elements. The element must be provided in available and balanced form. Available and balanced form. What do you mean by balanced form? If the element is at low concentration, lower than balanced form, that severely limit the yield and produces more or less distinct deficiency symptom is known as a deficient or deficiency. When an element is at low concentration, which severely limits yield and produces some more or less distinct symptoms, that is called as a deficiency symptom, and the process is called as a deficiency. It is lower than balance. Then another term is known as a toxicity or toxic element. When the concentration of either essential or other element is sufficiently high than balance, or that optimum, which high sufficiently high to inhibit the plant growth or retard to greater extent. That is known as a toxic element, or the process is known as a toxicity. What do you mean by available forms? Available forms is a chemical form of nutrient which is taken by assimilated by plants. Chemical form of elements, nutrient element that is used by plants for their growth and development. For potassium, the available form is K plus. For calcium, available form is calcium plus plus. For magnesium, available form is magnesium plus plus. Then iron, Fe plus plus. Manganese, Mn plus plus. That is known as manganese, and Mn3 plus, that is known as manganese. In copper, U plus plus, that is known as a copper, available form of copper. Then for zinc, Zn plus plus. For chlorine, Cl minus. For silicon, Si4 plus. Cobalt, Co plus plus. Sodium, Na plus, and other nutrients combined form, that is may be present in more than two forms, 2 to 3 forms. That is nitrogen. Nitrogen is available in nitrate form, that is NO3 minus. There is a more rapidly available form. Then ammoniacal form, that is NH4 plus. Then for phosphorus, H2PO4 minus, HPO4 minus minus, and PO4 minus minus minus. These are three forms, available forms of phosphorus. For sulfur, SO4 minus minus. These are available forms of sulfur. For boron, H3BO3, H2BO3 minus, HBO3 minus minus, and BO3 minus minus minus. For molybdenum, HMO4 minus, that is molybdenum, and most rapidly available form is HMOO4 minus. Then for carbon, you know that is carbon dioxide, nitrogen is 2. Classification of elements. Nutrient elements are classified into macronutrients and micronutrients. Macronutrients. Macronutrients are nutrients which are required in larger amount by plants. That is known as more than 50 ppm. more than 50 ppm, that is large, required in larger quantities, known as a macronutrient. It is classified into two types: primary macronutrient and secondary macronutrient. In primary macronutrient, nitrogen, phosphorus, and potassium are termed as the primary nutrients, and calcium, magnesium, sulfur are termed as secondary macronutrients. Then micronutrient. Micronutrient is required in smaller quantity, that is less than 50 ppm, is called as a macronutrient. Example of micronutrients are Fe, Mn, copper, boron, molybdenum, chlorine, cobalt, nickel. That is known as a micronutrient. Then, based on mobility of plants, some nutrients highly mobile, partly mobile, and immobile. The mobile nutrients are therefore termed as NPK and magnesium, that is nitrogen, phosphorus, potassium, and magnesium. In the partly mobile nutrients, iron, zinc, copper, and molybdenum as regarded as partly mobile nutrients. And the immobile or unavailable nutrients, calcium, sulfur, and boron. What do you mean by mobile nutrients? Mobile nutrients are those nutrients when deficient in the plant move from mature tissue, older leaves to young meristem. Thus, the deficiencies are manifested on the older tissue or older leaves. Immobile nutrients. These are those nutrients under the situation of deficiency in the soil cannot move from older to younger tissue, and its deficiency symptoms are first appear on younger leaves, that is freshly produced leaves.
Okay, next topic is
The next topic is
role of microorganisms.
role of micro.
Hello.
Hello.
Okay.
Okay.
Hello.
Hello.
Next topic
Next
is
topic is
soil organic
soil
matter decomposition.
organic decomposition.
Decomposition of
Decomposition
soil
of soil.
organic matter. Decomposition of
Decomposition
soil
of soil
organic
organic.
mineralization and
Mineralization and
demineralization. Okay.
okay.
What do you
What do
mean
you
by
mean by
soil organic matter? That's the
that the
organic
organic,
matter which
which
is a
is a
component of
component of
soil
soil,
which
which
contributes to
contributes to
5%
5%
in the
in the
components of
components of
soil. It is
it is
very
very
important part,
important part,
as you
as you
very
very
well
well
know that.
hello. Is it okay? Sound is okay? Hello? Anyone can answer in chat
Yes,
box.
sir.
Okay. Soil organic matter, that is one of the most important component of soil, which contributes around 5% of various components of soil. It is a quality aspects which enhance or improve the physical properties of soil, which are very necessary for producing quality produce. So soil organic matter, it is present in very uppermost layer of soil, which contains organic matters, O horizon, which is designated by O horizon. It contains partially decomposed and partially undecomposed organic matter. Partially decomposed and partially undecomposed organic matter. The various sources of addition of organic matter to the soils are includes, that is on-farm resources, that is cow dung, animal urine, stubbles, sugarcane trash, then hay. All these after decomposition contributes to soil organic matter. The various factors affecting soil organic matters are, which are enlisted as number one is the climate, that is arid and semi-arid climate, where rainfall is dominant. Where rainfall is dominant, will contribute to decomposition of organic matters, or it produces more organic matter. The natural vegetations, texture, and texture soil has more organic matter. Then drainage, good drainage soils has optimum organic matter. Cropping and tillage improves crop retention, residues, non-nutrients, and green manure crops are added organic matter efficiently. It is a composition of organic residues. It contains 75% moisture and 20% diameter. Okay. On the basis of decomposition, soil organic matter is classified on the basis of rate of decomposition. That number one, rapidly decomposing organic matter, which includes sugar, starches, and proteins, etc. Less rapidly decomposed organic matter includes sugar, starches, and proteins. Then less rapidly decomposed hemicellular cellulose. Very slowly decomposing organic matter, that is fats, waxes, lignin, etc. The very first and foremost important part for improving soil health is the decomposition of organic matter, which is accomplished by enzymatic oxidation of bulk with release of CO2, water, and energy. Then essential elements are released, that is NPS, with production of organic acids and immobilized by series of reactions. Hello? Sure. Gutambre, turn on your mic. हॅलो गुतांबरे ऐकायला येतंय का?
हा येते सर. हॅलो.
माईक स्क्रीनवरती कोण खेळते? स्क्रीनवरती रेस मारली ती कोणी मारली?
सर आवाज येत नाही क्लिअर तुमचा.
आवाज येत नाही तुला? कसं काय आवाज येईल? स्क्रीनवर कोण खेळतंय? स्क्रीनवर स्क्रॅचेस कोण मारतंय?
माहित नाही सर.
अरे
मी आता जॉईन झालो सर.
माहित नाही?
मी इतक्यात जॉईन झालो सर.
अरे तू शोध.
तर आवाज येत नाही
लक्ष द्या आता, बाकी सर्वांनी लक्ष द्या. हा एक मिनिट ऐकून घेतो जरा. मूर्ख आणि काय करतोस? आता कोणी स्क्रीनवर काही केलं, एखादी स्क्रॅच मारली, तर लेक्चर इमिजिएटली बंद करून टाकेल, लक्षात ठेवा. ओके. Decomposition of organic matter includes enzymatic oxidation. Then essential elements are released, that is NPS, with the production of very little amount of organic acids, that is carbonic acid H2CO3, and it is immobilized by a series of reactions. The last part, that is formation of compounds which are resistant to microbial reaction, that is known as humus. That leads to formation of humus, and that particular humus imparts black color to the soil. Okay, there are two conditions, aerobic and anaerobic conditions. In the aerobic condition, products formed are CO2, ammonia, nitrate, phosphoric acid, sulfate, and water, and essential plant nutrients that contains calcium, magnesium, and micronutrient like iron, copper, and zinc. The anaerobic condition includes methane, organic acid like H2CO3, then lactic, propionic, and butyric acid, NH4, various amines, and humic substances. Okay. For decomposition of organic matter, first we have to decompose soluble substances. Soluble substance, that is glucose. When glucose is decomposed under aerobic condition, the reactions that postulated are sugar plus oxygen, giving rise to carbon dioxide plus water. It is under partially oxidized condition. When it produces certain aliphatic acid like acidic, formic, citric, and lactic acid, which can be represented as C6H12O6 plus 2 oxygen atom, chlorocetyl alcohol plus carbonic acid. It has to go two processes for decomposition of soluble substances. Number one process is known as ammonification, that will convert complex organic nitrogen of two polypeptides, then peptides, then amino acid, then NH3 or NH4. It's called as ammonification process. The transformation of complex organic nitrogenous compounds like amino acid, amides, nitrates into ammonia. This is the result of hydrolytic and oxidative enzymatic reactions. The number two process for decomposition of soluble substances are nitrification. This is the most important reaction or process which converts ammonia into nitrates. Ammonia into nitrates and then to nitrate. And then this process is called as nitrification. And the form NO3 minus is most usable form and can be easily assimilated by plants. Then the reactions are as follows: NH4 plus O2 giving rise to NO2, that is nitrites, then plus 2 hydrogen atom plus H2O plus energy giving rise to NO3 minus plus energy. That is most acceptable form of nitrogen. Most acceptable and available form for easily assimilation of plants. Then denitrification. The process involves conversion of cyanide nitrate into gaseous nitrogen or nitrogen oxide. It is called as a denitrification. This process is with the help of Pseudomonas or Bacillus. Then under anaerobic condition, reactions are glucose undergoes reaction which produces lactic acid and butyric acid. Then second most decomposition of organic matter is decomposition of insoluble substances. Number one is a breakdown of protein. During the course of decomposition of plant materials, the proteins are hydrolyzed to intermediate products. The first process is known as the aminization. The process of conversion of proteins into amino acids is called as aminization. Then ammonification, the process of conversion of amino acid and amides to ammonia. Then later on nitrification process and the conversion of nitrate to nitrate. Then second, breakdown of cellulose. It is accomplished by hydrolyzation of cellulose with production of organic acid, which produces carbon dioxide and water. This is a slow process in acid cells. Then breakdown of hemicellulose. It decomposes faster than cellulose and hydrolyzed to sugar and uronic acids. The sugar therefore attacked by microbes to produce organic acids and uronic acid broken into pentose to produce humus. Then breakdown of starch. That is the glucose polymer first hydrolyzed to maltose by action of amylase. Then maltose is converted to glucose by maltase enzyme. By ether-soluble substances. Then decomposition of lignin. It is a very slow process, much slower than cellulose. It demarks complete oxidation giving rise to carbon dioxide and water. Then last part that is simple sulfur containing organic compounds which are converted to sulfuric sulfates SO4 minus plus A plus plus energy by sulfur oxidizing bacteria such as thiobacillus thioxidant and thiobacillus peroxidans. These are two sulfur oxidizing bacteria. Then mineralization. Biological conversion of organic forms of carbon, nitrogen, phosphorus, and sulfur to inorganic form or mineral forms is called as a mineralization. And the reverse process is called as a immobilization. Immobilization marks conversion of inorganic forms of carbon, nitrogen, phosphorus, and sulfur by the soil organism into organic forms is called as immobilization. Then various factors for decomposition are temperature, then soil moisture, then nutrients, soil pH, soil texture, and other factors. Other factors include toxic elements of phytotoxin, plant material. Okay. And last part, that is role of microorganisms for decomposition of organic matter. As you know, organic matter having micropores create a granular condition of soil which maintain aeration and permeability. Organic matter is regarded as food for microorganisms. So decomposition rate is most part, and there is increase or multiplication of organisms, soil microorganisms, soil microorganisms. Then it increases water holding capacity of soil, reduce surface runoff, erosions, and having good infiltration due to addition of organic matter. Then surface mulching with coarse organic matter, lower wind erosion, and conserve soil moisture. The fresh organic matter is supplies food for earthworms and rodents, make soil P readily available. Then organic acid, which are released in minute quantity, help for decomposing organic matter to reduce its alkalinity with the help or addition of sulfur decomposing microorganisms, which decompose or oxidize sulfur, producing sulfuric acid, and bring back the pH of soil to neutral level. Then humus is a storehouse of nutrients in exchangeable and available forms. Then organic matter act as a buffering agents which check rapid chemical changes in pH and soil. Okay, it is all about organic matter decomposition. After decomposition, the product form is known as the humus. The humus can be defined as complex and rather resistant mixture of brown or dark brown, amorphous and colloidal organic substance that results from decomposition and synthesis and has chemical and physical properties of great significance to soil. Humus formation is organic colloid that is have size less than 1 millimeter, 1 micrometer in size. It attributed by number one, decomposition process, then synthesis, that is in synthesis involves breakdown products of lignin as phenols and quinones. Which produces non-humic group and humic group. Are the two major fractions of organic matter. Okay, it is all about decomposition of organic matter and humus formation. If there is any question related to this topic, you can turn on your mic and ask the question. EPT. If there is any question, you can turn on your mic and ask the question. If there is no question, then we will end the meeting within a minute.